Hello. Lucas Millhaupt has been providing manufacturers with brazing products for over 70 years. Our technicians are pleased to share information on brazing techniques and products. Today we'll discuss open-air brazing of copper to metals such as steel with our Handy One flux cord products. This is different than torch brazing copper to copper, where no flux is required. Open-air brazing of copper to other materials, such as steel, requires the use of a flux. The flux allows the brazing alloy to properly wet the base material. Traditional torch brazing of copper to steel involves the use of a brazing alloy rod or ring used in conjunction with a paste flux, which is applied in a separate step prior to heating. Manual flux application can be inconsistent, resulting in variations in the brazing process, and can affect braze quality. Variations in flux weight can change heating requirements. Too much flux can cause excessive voids. Too little flux will limit alloy flow and penetration into the joint. Handy One products precisely control the alloy to flux ratio and allow the operator to apply flux to the joint during the heating process. This eliminates a pre-braze processing step. There are several alloy options in the Handy One product line. For this demonstration, we'll be using Braze 560. Handy One flux cord wire is a combination of brazing alloy and flux in one form. Braze 560 is the lowest temperature cadmium-free alloy for the brazing of copper to steel or other base metal combinations. Braze 505 is a multi-purpose alloy with intermediate melting temperature, and Braze 380 is a low silver alloy with intermediate melting temperature. The advantages of Handy One are no separate flux is needed. There's consistent alloy and flux application, resulting in improved joint consistency. Let's walk through the process of brazing copper to steel with Handy One Braze 560. Remember that a joint gap of 0.02 to 0.05 of an inch is preferred on each side. First, clean both the copper and steel materials to remove any dirt, oil, or other potential contamination. Mechanically roughen the outer diameter and inner diameter surfaces. Next, heat the joint area. We're using an oxygen acetylene torch, however, air acetylene with a proper tip or any fuel gas that can rapidly heat copper would also be suitable. A reducing flame is recommended. The flame should be soft enough and large enough to envelop both the components. Heat should be applied starting at the joint line and working up, down, and around both base materials. You should see a color change in both base materials. Take care not to overheat the steel and copper. Apply the Handy One alloy to your joint surface to test the temperature. If the base material is at a suitable temperature, the flux in the cord product will flow out from the wire, preparing the metal surface for alloy flow. Continue heating the base materials and apply the rod to the joint until you observe melting of the alloy. Focus heat to the outside tube to draw the molten alloy into the interface of the joint. Experience will dictate the amount of alloy you apply. Then allow the alloy to solidify or cool prior to moving the component. Flux residue is corrosive and should be removed after brazing. This can be accomplished in numerous ways, but quenching of the assembly in hot water after the alloy has solidified or wiping the joint with a wet rag are common methods. Finally, inspect the joint for any gaps or voids. To summarize, the steps for brazing are: clean the parts and roughen the surfaces, heat the joint area and watch for a color change, apply Handy One, continue heating the area, then allow the part to cool, remove flux residue, and inspect the joint. For more information on brazing, please visit our website or contact your Lucas Millhaupt representative. Thank you.